Okay, now we're going to start a new session. This one is talking about more topic about the slope, or so you can say that it's either called a more on slope, or to be specific that I mentioned about a parallel, perpendicular, and the average rate of change. So let me just talk about that. Okay, so think about the line. We learned about the linear equation and you can graph it. And a quick review, we have m equals m, y equals mx plus b. And this is the slope. Slope positive means from left to right you're going up. Slope 0 means it's a flat straight line. And a slope negative, which means you're going down. Okay, now, and also by the definition, the slope is rise over run, right? So what happened if you have two lines and they're parallel to each other? Parallel to each other. You know what parallel means? Parallel means just like the rail track. They're just the distance between them maintains the same, and they will never meet, they never go cross, and they will never be too far or too close. So it keeps like this. So if you have if I have two lines, they are parallel to each other, which means their rise over run are exactly the same, right? So in that way, for the parallel lines, two line, we call this L1 or L2, then that M1 should be the same as M2, which means the parallel lines have exactly the same slope. Okay, so what about the perpendicular? Perpendicular means they're going to form a 90-degree, right? So if this slope is this slope is M1 and this slope is M2, and what would be the relationship between these two? First of all, if this is a positive, then the other one must be negative. So at least you're going to see that's the opposite sign. And then for the rise over run, okay, for the M1, the rise over run, and in this way, it was like this, right? This is the rise. Actually, it's going down, and this is a run. So this rise becomes this run. You see that? So therefore, M1 should be negative reciprocal of M2, or M2 equals negative 1 over M1, or M1 times M2 equals negative 1. All these three says about the same thing. So I think the easy way to remember is two perpendicular lines, their slope would be the negative reciprocal of each other. All right, so that is the general idea that we're going to learn in this session, and we're going to work on some real questions so you can get some exercise. Now, I ask you to find the equation of a line passes through a point. Okay, so I know a point -3, 1. Okay, and parallel to the line whose equation is y equals 2x plus 1. So this is a question. Think about that. We're looking for the new line. We try to find the equation of the line. Okay, that passes through this point. That's a point. That's a point. Okay, and a parallel. Okay, every time when you see parallel, which means they should have exactly the same slope. So this is the old line, right? This is a new line. All right, and then so for the old line, what is the slope of the old line? I just call this as given line, okay? Given line or new line, it's the same thing. That is, we call that as M1, which is 2, isn't it? Therefore, the new line should have the slope also 2. All right, and also for the given line, we also know a point, -3 and 1. So point slope formula, which is, do you remember that? It's y minus this y over x minus this x, -3 equals the slope. All right, now we simplify this. We get a y minus 1 equals 2 times, and here is x plus 3, which is 2x plus 6. And then we just need to add plus 1 on both sides. So my equation becomes y equals 2x plus 7. That's my solution. All right, now let's do a quick review. There are 2 lines. The first line is given. The first line, the equation is given. For the given line, the good thing is we already know the slope. Okay, and then for the new line, because we know they're parallel to each other, so the new line must have exactly the same slope. And also 1 point is given, so you can just find the equation. If you forgot about that, go back to my old, my previous video. All right, now let's try one more. I ask you to find the equation of a line, a new line, okay, that passes through -3, 1. It sounds familiar, okay? And here, perpendicular to the given line or old line, whose equation is this, is y equals 2x plus 1. All right, now the only difference is this, it's perpendicular, and the previous example shows it's parallel. So I want you to be very, very careful when you work on this problem, because I have seen this so many times. The students don't pay enough attention. Okay, this is the key word. You have to be able to recognize the key word here, perpendicular. And the other one, the previous one, here is the key word, parallel. Okay, I feel so sorry when they make the mistake and they didn't pay attention to the key word. All right, now the old line, the slope, or M1, is what? 2. So for the new line, the M2 should be, okay, now I want you to repeat, negative reciprocal. So which is -1 over M1. And then M1 is 2, so that should be -1/2. That's the slope of our new line. And also I have a point. So y minus 1 over x minus -3 should be -1/2. All right, now this, I multiply by this on both sides, so I get a y minus 1 equals -1/2 times x plus 3. Okay, you should be able to know how do I get this plus 3, right? Because that's a minus negative. All right, so that's going to be -1/2 x -3 over 2. Again, I just need to plus 1 on both sides, so I get a y equals -1/2 x. What is -3 over 2? That's -1.5. -1.5, then plus 1, I get a -1/2. So this is my answer. All right. Now the good thing about this, I think, starting from here, everything in this section, you can always, you're okay to check your answer. For example, you know the slope. Slope is not 2, but a -1/2. Is that right? Yes. And it will pass through -3, +1. Is that right? If you're putting x as -3, so that -1/2 times -3, you get a +3 over 2, minus 1 over 2. You do get 1, so that is right. So before you submit your answer, you should be able to check and to make sure that you get the right answer. All right. Now I want you to tell you one special case is this is a vertical line, this is a horizontal line, right? Horizontal, and this is a vertical. What happened to their relationship? They are perpendicular to each other. Usually I use this to show that it's a 90 degree, or they form a 90 degree. So that's a perpendicular. And this slope, it's a 0, and this slope does not exist. Okay? So we know a vertical line and a horizontal line are perpendicular. All right, now we're going to keep going. I will ask you to find the equation. Find the equation of a line that passes through 3, -5 and perpendicular to the line. It sounds familiar, right? I think right now you're very confident. Say, yes, I know how to do it. To the line whose equation is x plus 4y minus 8 equals 0. Whoops! This is not given in that slope-intercept form. If it's given by the slope-intercept form, we're very happy because we know the slope already and we know the perpendicular, so we just do the negative reciprocal, we get the new slope, and we have a point, and then we can do it. Right? But this is a standard form, so we cannot do that. A two-way to do that, okay? Number one, you just transform this from this general form to a slope-intercept form, which is you leave 4y and you move everything to the other side. Okay, so basically you're subtracting x and you plus 8 on both sides, and then you divide it by 4, so that's going to be -1/4 x, and then divide by 4, you get 2. So now you know the slope of the old line. Therefore the m1 is -1/4. So what about m2? Remember, negative reciprocal. So negative becomes a positive, reciprocal of this becomes a 4. Hey, I get the slope. And I know 3, 5. I know 3, -5 as the point. Again, I'm going to use y minus -5 over x minus 3 equals 4. So I go y plus 5 equals 4 times x minus 3. So that's a 4x minus 12. And then I go ahead, I need to subtract a 5 on both sides. Therefore, I got a y equals 4x, -12, -5, I get a -17. So that is my answer, okay? This is the very traditional way. That's how you should do it. There's another way. I don't know whether you can remember this, but I will tell you this, okay? So if your line 1 looks like ax plus by plus c equals 0, and the line 2, if it's a parallel, that means they have the same slope. The relationship between the a and b stays the same. We just need to know the last number. So we should have ax plus by plus we don't know equals 0, okay? If the line 2 is a perpendicular, then I tell you what, you switch a and b and change the sign. So you should have bx minus ay plus a number equals 0, okay? So this number we're going to figure out later, but this is the easy way to remember that. If you like, I think you might want to take a little note about that. So if we have this line, x minus 4y, sorry, x plus 4y minus 8 equals 0, and then we're looking for the new line that is a perpendicular. We're going to switch this and change one sign. So I should have 4x minus y plus a number which we don't know equals 0, isn't it? Okay. Now, in order to find out this number, we have to put in the point 3, negative 5 in here and here. So there will be 4 times 3 minus the y is negative 5 plus this number, just leave that a box, equals 0. So 4 times 3, which is 12, plus 5, because minus negative 5, right? And then plus the box equals 0. So 17 plus whatever we're looking for is 0. So what is that? That should be negative 17, isn't it? All right, now once we know negative 17, we just put it back. So the equation looks like 4x minus y minus 17, can you see what I'm doing? Equals 0. So you can write your answer like this. Now you compare these two. Are they the same? They are, because if you move a y to the other side, which is the same as this one, is y equals 4x minus 17. So when you give me your answer, then you can do either way. And this is called a slope-intercept form. This is the general form. So that's the two way to do it, okay? So far, so good. All right, now, when we have a line, have a linear equation, linear function, when we graph it, we get a straight line, and then we can find the slope. And the slope is the changes in y, the change in y over the change in x. What happened if you have something not linear? If you get something from a curve look like this, like this. So I want to know from here to here. All right. Do you remember what was it? It's a difference quotient of a function, right? So this is the x1, y1, and here is x2, y2. But the difference between what we learned earlier was it was a straight line. So the guy comes from here, he walked to there on a straight line. But if you walk along this curve, then it's not a straight line. However, if we just look at the starting point and the ending point, we can use y2 minus y1 over x2 minus x1. What is that? That's the slope, right? Slope. And or we say delta y over delta x. Delta means change. Okay, so this is what? This is the slope of the line passes x1, y1, and x2, y2. Even actually it's not working directly, it's walking like a curve, right? It goes here. So we still call that, and there's a name for that. We call this as average rate of change. Okay. Again, this y is a function of x. Therefore, you can just write the y is f of x. So we can say that's the function at the second x value, function value, and minus the function of the first x value and over x2 minus x1. Do you think this looks familiar? It does, right? Remember we used to did one question earlier from x1, we go to x2, but we just increase by h. Do you remember that question? If not, it doesn't really matter. Okay. All right, now, well, I'm going to ask you to calculate the average rate of change, give you a function and give you 2x value. For example, I ask you to find the average rate of a change of, okay, I give you the function of x, f of x equals x squared from x1 equals 1, 2, x2 equals 2. So when x goes from 1 to 2, what is the average rate of change? We need to find out y1, which is f of x1. And then f of x is x squared, so that would be f of 1, right? x1 is 1. So that would be 1 squared, which is 1. And the y2, which is f of x2, which is f of 2. And that is 2 squared, which is 4. I'll give you 1 second. You might want to see, how do I get it? All right, now what is the average rate of change? By definition, is y2 minus y1 over x2 minus x1. So that will be 4 minus 1 over 2 minus 1, 2 minus 1. So the answer is 3. So that's the average rate of change. Okay? All right, now let me ask you to do one more. I keep this here. I hope I have enough space. Now I do one more. I go from x1 equals 2 to x2 equals 3. Again, I find y1, which is f of x1. Okay, so that is f of 2. And the function is x squared, so that is 2 squared, which is 4. And y2 will be the function of x2. So that's f of 3, because we go 2 to 3, right? And here's a 3 squared. It's almost out of ink. So that's 9. Therefore, the average rate of change will be 9 minus 4 over 3 minus 2. That is 5. Okay, now you see. When x goes from 1 to 2, just increase by 1. And then the y value changed by 3. But when x goes from 2 to 3, also increased by 1. Y increased by 5. Did you see that? It changes faster. That's pretty much the same idea like a speed, right? When time goes from the first minute to the second minute, from second minute to the third minute, and the distance it traveled is 1 to 4, so the speed is 3, and here's the speed is 5, which means this guy travels faster and faster. Or when you graph this, x equals y equals x squared, it looks like this. Okay, so here's a 1. Oh, sorry, here's a 2. Okay, and here will be 3. So when x from 1 to 2, so that's a 4. Okay, so see, okay, and then when x equals 3, it goes up to here, that is 9. You see that? It changes faster and faster. Okay, so I think the book, or you might want to work with this, the average rate of change. We also call that the average velocity or the average speed, which is the change in distance over the change in time. Okay, if I give you the formula, the distance is a function of time, then you can do it. All right, now I think I'm not going to detail about that, but so far, as long as you understand all those, I think you're good enough. You understand more on slope. You understand the parallel, you understand the perpendicular, and you understand the average rate of change. Actually, the reason you're going to see this a lot, the average rate of change, you're going to see this quite a lot at the beginning of your calculus class later. That's why they keep putting this in this pre-calculus class. All right, so that's all for this session.